Welcome to iPexpert's vLecture series. Today's topic is going to be private VLANs. My name is Marko and I will be your instructor for today. Now, what are private VLANs? Private VLANs are a way to isolate traffic in the same broadcast domain in a smaller broadcast domain, to create a sub-broadcast domain in already existing VLAN. So, in essence, when we have a single switch, we know that that single switch is a single broadcast domain. This single broadcast domain means that traffic sent from one port in one VLAN will be delivered or could be seen on all ports on that switch that belong to the same VLAN. That means that traffic sent from here, even though it may have been required to go just outside of this port, if it goes out to an unknown MAC address, the MAC address that has not been learned by this switch in the broadcast domain, it may be sent out to these ports here, which allows the ports, the hosts connected behind these ports to actually communicate to each other. This is the basic functionality of Ethernet, and this is something that is really truly desirable in Ethernet networks. But sometimes we have the need to actually isolate the traffic inside the same broadcast domain and actually disallow this communication from actually happening. Now, there are multiple ways we can actually accomplish that. One of the ways would be to actually separate these broadcast domains and create multiple VLANs. Now, if we created multiple VLANs in our network, we would have several scaling issues. One scaling issue would be the sheer number of VLANs that we would require for this to work. Now, in some environments, this may or may not be the problem. If you have only 10, 15, 20, 30 VLANs in your network, this is really not a big problem. But what if you have 4,000 VLANs, or maybe even more? This becomes an issue. Another scalability challenge here is the number of IP subnets that you would need. Why? Because if we separate this traffic here, from this traffic here, from this traffic here, if these want to communicate, they would actually have to communicate on layer 3. And if they need to communicate on layer 3, that means that we need an IP subnet 1 here, we would need IP subnet 2 here, and IP subnet 3 on this side. Now, when we divide the network into these multiple IP subnets, we are going to be losing 2 IPs per subnet. Why are we going to be losing 2 IPs per subnet? Well, because what we need to have is the broadcast, apologies, what we would need to have is the network part, the network address, and of course the broadcast address, the last IP in the subnet, which means that 2 IPs from the subnet are going to become pretty much useless or unused in our network. Now, to address these issues, many networking vendors came up with the solution for this. Now, first Cisco's approach to actually provide a scalable solution to actually allow this division to isolate the traffic inside a broadcast domain without the need to create additional VLANs or additional IP subnets was actually a protected port feature. Now, with protected ports, what we had on a single switch, we could inside the VLAN designate certain ports to be protected. And other ports would be just normal ports. So let's say that these here were normal ports. Now, normal ports could communicate with each other and normal ports could communicate with protected ports. However, the traffic between the protected ports was not allowed. Now, this was a very simple feature and it's actually very simple to configure. All we have to do is go on this particular port and say switch port protected. When we do this, we are automatically creating this barrier, this filter in layer 2 communication between these 2 ports. And we are still allowing the communication with these normal ports. But there is a problem with this approach, again, of the scaling nature. What if we had more than one switch? What if we had 2, 3, 4, 15, 20, 2,000 switches, but it's enough to have just 2? So let's say that these 2 ports here were protected ports. And let's say that we had a very, very similar setup on this switch here. And these switches were interconnected with trunks. Now, the configuration on this switch here, let's call it switch 1, and let's call this one switch 2, allows for this filtering to happen. So there will be no communication between these protected ports. But when the traffic is actually sent across this switch here is unaware of this configuration on switch 1, which basically allows the traffic to go from one protected port to another protected port. In other words, between the switches, we no longer have this capability to isolate the broadcast domain. So protected ports were an interesting solution for a problem that scaled to one switch exactly. But what happens when we have multiple switches? Well, this is where private VLANs come into play. And the private VLANs are Cisco's invention, but interestingly enough, they are actually documented in an RFC. So if you're really, really curious about reading the RFCs, and when you're preparing for your CCI lab exam, you should be reading RFCs from time to time, you may want to look at RFC 5517, which is the private VLAN RFC. So let's take a look at how private VLANs actually solve this problem and how they can scale across multiple switches. Well, first things first, they solve the problem by using 2 VLANs, or as the RFC says, they use the VLAN pairs. Now, one VLAN in this VLAN pair is going to be the primary VLAN, and then we are going to have a secondary VLAN. Now, primary VLAN, I like to think of the primary VLAN as the container for secondary VLANs. Secondary VLANs can be of 2 types. We can have isolated VLAN and we can have community VLAN. I will first explain what isolated VLAN does. Now, when we have a switch, again, a single switch that has multiple ports, what we want to do is, let's say that we want to isolate the traffic in these 3 ports. We do not want these 3 ports to be able to communicate with each other. Now, this is what we can solve using protected ports, or also we can use isolated VLAN for that purpose. So what isolated VLAN actually does is the exact same feature, apologies about this, is the exact same feature as the protected ports. They provide with pretty much the same functionality as the protected ports, except they can actually span across multiple switches, which is something that I will explain in a moment. So when we create an isolated VLAN, the communication between these isolated ports here will not be allowed. But these ports here, if we leave them to be just normal ports, we will still not allow any communication here. So let's designate this one port here as a special port. We're going to call it the promiscuous port. Now, promiscuous port in private VLAN terminology is the port that is allowed to communicate with isolated ports. So these ports here are all in the same VLAN, in the same secondary VLAN, in isolated VLAN, and this port here, the promiscuous port, is just designated to be the promiscuous port. So there is no separate VLAN for this. Now, a third type of VLAN, or actually the second type of the secondary VLAN, is something that we call the community VLAN. Now, let's say that we had these 2 ports. So let's designate them, for example, ports 5 and 6. So let's say that this is 1, 2, 3, 4, 5, and 6 here. Now, these 2 ports here belong to, let's say, the same customer or these two ports belong to a cluster of servers that you actually do want to provide direct layer 2 communication between, but you still do not want to allow the traffic between these ports to actually go here or here, but you still want to communicate with promiscuous ports, which could be, for example, very common case, could be an internet gateway. Now, if we have this situation that we want to allow the communication between these two ports and between the promiscuous ports and these community VLANs, but not outside of this tiny little community, this is when we would use the feature called the community VLAN. So going back to this example here, the community VLAN here allows the communication inside the community but not with other ports, other isolated ports. But what if we had a situation that we had multiple communities, that we had multiple unrelated clusters? So let's say that we had situation like this, that we had these two clusters and that we had multiple ports that we actually needed to provide the isolation between. Well, what we can do in that case, we can designate this as one community and we can designate this pair of ports as community number 2. And we can have as many communities as we like. So we can have multiple community VLANs associated with this one big broadcast domain. However, we can still have only one isolated VLAN. Why is that limitation there? Why do we need just one isolated VLAN? Well, think about it. These ports cannot communicate between each other. So what would be the need, real need, to actually use a different VLAN ID here when these are already isolated? They cannot communicate between each other. So real requirement here, or the real reason why we can have only a single isolated VLAN in this arrangement is because we really have no need to have more than one isolated VLAN. Now, we can have multiple community VLANs because we can have multiple arrangements like this where we have different clusters. So let's go back here and let's say that we can have only one isolated VLAN per primary VLAN. Now, we can have multiple community VLANs per primary VLAN. But what about the promiscuous ports? What happens if I wanted to have multiple internet gateways, if I wanted to have more than just one? Is that possible? Well, it is entirely possible. We can again have any number of promiscuous ports that we like. So we can have a situation where we have our switch here that has, let's say, community 1, that it has community 2, that it has these isolated ports, so let me isolate them somehow. And let's say that we want to have a redundant set of internet gateways. Now, both these ports here would be declared to be promiscuous ports. Now, when you declare port as a promiscuous port, you not only have to associate it with the primary VLAN, but you actually have to associate it with the secondary VLAN as well. Now, why is that the case? Well, because we could have a situation that we have this promiscuous port here. So let's say that this is also promiscuous port. But this promiscuous port, let's say it's designed only to service the isolated VLAN, but not to service these two community VLANs. In other words, I want these ports here to use this internet gateway here, and these ports here to use these redundant internet gateways. If that is the case, I can associate this primary port here, this promiscuous port in the primary VLAN, with only this secondary VLAN. I'm not going to be servicing these secondary VLANs. Now, this might sound a little bit confusing, but there is a very, very good reason why we have this hierarchy, why we have two VLANs in use. Because let's go back to the original problem, to the problem of multiple switches. So what happens when we have more than just one switch? Well, let's take a look. So I'm going to now use an example of two switches here. So let's say that we have switch 1 and we have switch 2. Now let's say that here on this switch we had a port that was in isolated VLAN. I'm going to have a switch here that is in isolated VLAN. So this is isolated VLAN and this is isolated VLAN. Now, given that both these switches are configured the same way, meaning that they're both agreeing that these are isolated VLANs, that they are using the same primary VLAN in the configuration, meaning that there is no mismatch, which is something that I'm going to show you a little bit later on. This is how this is going to work. Now, when the traffic arrives on this port here, and let's say that these ports interconnecting switches 1 and 2 are just regular trunks, so they're not really configured in any special way. They're allowing all the VLANs to go through. So let's say when the traffic arrives on this port here, and let's say it's a broadcast frame. Now, when the broadcast frame arrives, we need to send it out on all the ports in that VLAN except the port on which the frame arrived on. Now, if we have another isolated port on this switch, obviously this port will not be included in this replication because this is the whole idea behind the isolated VLAN. But what's going to happen with this frame is that it will actually be sent out of this trunk. So now it arrives on this port here, which is neither in isolated VLAN, it is not in a community VLAN, it's not a promiscuous port, it's just a regular trunk port. So will this traffic actually be sent out of this port here? Well, because the way private VLANs work, this is actually not going to happen. So this traffic coming in will not be sent to isolated VLAN. But what if we had a promiscuous port here? So let's say that this was promiscuous. Will this traffic be sent out of the promiscuous port? Well, the answer in that case is yes. But what will be the VLAN ID that is carried on this traffic? Let's say that the primary VLAN was 100 and that our isolated VLAN was 101. When we send this traffic, when this frame goes out of this port, will it be tagged as VLAN 100 or VLAN 101? Well, if the traffic goes in this direction, it is sent by the isolated port and it goes out of this interswitch connection on this interswitch port, this interswitch link, it will actually be tagged as the secondary VLAN. So it is going to go out tagged as 101. Now, when it arrives here as 101, and if this port here is actually associated with both the primary VLAN 100 and the secondary VLAN 101, it will actually be sent out here. Now, because this switch here is actually configured with 101 as the isolated VLAN, when we receive the traffic from a non-promiscuous port that is supposed to go to the isolated VLAN, we are actually not going to send this traffic. This is why this traffic doesn't go out of this port here. But what happens with the return traffic? So let's say that now this promiscuous port needs to send traffic back here. What is going to happen in this case? Because we just learned that if we send this traffic over the switch in VLAN 101, and given that this switch now is configured with 101 as the isolated VLAN, which we know it is, we know that this switch will drop the traffic. This is why the return traffic going from the promiscuous port, will actually be tagged as the primary VLAN ID. So this traffic going from switch 2 to switch 1 in response to this traffic will actually be tagged as the primary VLAN ID. Now, when this traffic arrives back to this switch, it is arriving on a non-promiscuous port, which means that we have to look in the tag that is configured there. So what is going to be the tag? The tag is going to be 100. This is the primary VLAN. Now, if we receive the traffic on a non-promiscuous port, the switch is going to assume that this is a connection to another switch and that the arriving traffic, therefore, must be arriving from a promiscuous port on the other side. If this is the case, then this traffic should be sent actually to our isolated port. So you can see here that actually in private VLANs between switches, we have this asymmetric VLAN tagging. So traffic in one direction will be tagged with the secondary VLAN or the isolated VLAN tag, but the traffic in return, in response to this, will actually be tagged with the primary VLAN ID, with the container's VLAN ID. Now, this is all fine with isolated VLANs. But what about the community VLANs? How do community VLANs actually work between the switches? Let's take a look at that. So again, similar scenario now. And we have switch 1, we have switch 2. And let's say that we have ports here that are in community VLAN. So we have, again, primary VLAN, let's say 100, and let's say that we have community 1, which is 102. Now, when the traffic gets sent across this switch as the result of the community port actually receiving this traffic, it will be sent tagged just like in the previous case with the secondary tag. Now, when it arrives to this switch, it arrives on a non-community port. It arrives on a regular trunk port. So these are regular trunk ports, just like in previous example. Now, when the traffic arrives on a trunk port and is tagged with the community VLAN, well, we don't really have to think much about it. This traffic should be sent out, because if it arrives tagged with our community VLAN, that means that it was sent by the community port on the other side. The response traffic is going to go the same way. Now, if we have the promiscuous port, again, this is the promiscuous port, and we want to have communication between these two ports, again, traffic in this direction will be tagged with the secondary VLAN ID, but the traffic in this direction will again be tagged with the primary VLAN ID. So traffic from the promiscuous port going to either community ports or isolated VLAN ports will always be tagged with the primary VLAN ID. Traffic between the members of the same community VLAN will be tagged between the switches with the secondary tag, and in isolated VLAN the same way. So really, to understand what is going on here, let's create a very, very quick table. So let's say that we have situation that we have an isolated VLAN. Let's say that we have promiscuous VLAN. Let's say that we have community 1, that we have community 2, and that we have just a regular trunk port. So let's repeat the same thing here. So we're going to have the isolated VLAN, the promiscuous port. This is going to be community 1, community 2, and let's have the trunk. So what's going to happen here if the isolated port tries to send traffic to isolated port? Well, that will be denied. That traffic is not going to be sent. Well, if isolated port tries to send the traffic, it will actually go out of the promiscuous port. It will not go out of community 1 or community 2 members, and it will actually go out of the trunk. This is this situation that we had here. The traffic from an isolated port was actually going over the trunk to another switch. Now, when we have promiscuous port sending the traffic, it will be actually sent to isolated ports. It will be sent to other promiscuous ports, community 1, community 2, and over the trunks. When community 1 sends the traffic, of course, it doesn't go to isolated ports. It will go to promiscuous ports, it will go to promiscuous 1, but it will not go to community 2, and it will go out of the trunk. Now, community 2, it will not be sent here, it will be sent here, not sent here, it will be sent to community 2, and it will be sent out of the trunks. Now, traffic coming from trunks, remember this situation here. Traffic going, excuse me, not that one, was it? No, yes, it was this one. So traffic coming from promiscuous port, or traffic coming from isolated VLAN here, going over the trunk, or in this direction, I believe we had that case. So there was this isolated port sending the traffic, and it's arriving on the trunk. So this is what we are looking for. Is this traffic here going to be replicated to isolated port? The answer is no, because if we send this traffic, we are not going to provide for isolation between the two switches. So the traffic here will not be sent from the trunk to isolated ports. And keep this in mind, and even in RFC there is a note about it. There is an asymmetric behavior. Traffic from isolated port will actually be sent out of the trunk, but traffic from the trunk will not be sent to isolated ports. If it's tagged with the secondary VLAN ID, if it's tagged with the primary VLAN ID, we can assume that it is actually coming from the promiscuous port on the other side, and in that case, it will be sent. Now, traffic coming from trunk will go to promiscuous ports, will go to community 1 ports. Well, actually, it will not go to community 1 ports. Let me see, let me think about that. If it's tagged with, oh yes, it will. If it's tagged with the secondary ID, yes, it will be. The community 2 as well, and it will go to other trunks. So here I'm just going to put the note. This is if traffic is tagged with secondary VLAN ID. That means if the traffic is arriving, for example, from one community port, when it goes over the trunk, it will actually be sent to that community port. But in the case of promiscuous ports, the situation that we had here, in this example, we are not going to have that case. Where is that example? Here it is. So in this case here, we are not going to have the traffic going from, sent from an isolated port, going over the trunk. From trunk, it will not be sent to isolated port if it was tagged with the secondary VLAN ID. So this is the theoretical behavior of private VLANs. But this is all fine and nice. Now let's see this in action. So what I'm going to do here is I'm going to set up a very simple network. I now have to reference the diagram that I have made for myself. The first thing that I'm going to do is I'm going to use 2 switches. And for this, of course, I'm going to use the stuff or the equipment in Proctor Labs. So I'm going to have 2 routers. This is going to be R1. And on switch 2, I'm going to have R6. So this is going to be port 01, this is going to be 06, it's going to be 00 on this side, and this is going to be 024. All are fast Ethernet ports, so I don't have to actually write that down. So what I'm going to set up here is, I want this here to be a private VLAN setup, and I would like R1 here to be in isolated VLAN, and I would like R6 here to be a promiscuous port. So my primary VLAN ID here is going to be 100, and isolated VLAN, let's say that it's going to be 101. Now, what are the prerequisites? What would be the prerequisites for me to actually configure this to work? Well, in the iOS that I'm using, and the one that is most likely going to be used in your CCI lab, the prerequisite is that we have to use VTP in transparent mode. That's the first thing that we have to do. Now, with VTP version 3, the things have changed just a little bit in that sense, but for now, we're just going to stick with VTP transparent. The other thing is, what we need to do is we need to create the VLANs. So I'm going to create the primary VLAN. Then I need to create secondary VLAN. configure secondary VLAN, declare it as the secondary, and finally I need to configure primary VLAN. Now, it doesn't make sense that actually we create the primary VLAN here and we configure it here. But the problem is that this configuration here, the configuration of the primary VLAN, actually deals with associating the secondary VLAN with the primary VLAN. So if I don't create the secondary VLAN, I cannot associate it with the primary VLAN. Now, I could first create the secondary VLANs and then create and configure primary VLANs, but somehow in my mind, this approach makes just a little bit more sense. Now, another thing that I'm going to do here is these two switches, my switch 1 and switch 2, are pretty much unconfigured. I don't have any pre-configuration on them, so I'm going to start from scratch. So what I'm going to do here is I'm going to connect to my switch 1 and switch 2, and I'm going to start with, as you can see, unconfigured switches. I'm going to start with very, very basic configuration. I'm going to cheat a little bit. I'm using a shortcut macro here that is going to put some basic pre-configuration on these switches for me. So I'm going to give them the host name. And what I would really like to do is I'm going to shut down all the ports except the ports that I am actually going to be needing. So I don't want any other ports to be up and running on these two switches. So let me do the same thing on Cat2. So this is going to be my Cat2 interface, range fastnet 01 to 23, gigabit 01 to 2, shutdown. Now, what I usually do is I use the text editor for editing my configuration. So let me bring in the text editor here. So the next thing that I'm going to do is I'm going to change the VTP mode to be transparent. Let's do that. And last thing is interface fastnet 24. I'm going to make it a trunk. So switch port trunk encapsulation.1q, switch port mode trunk. Let's make sure it's actually up and running. So this goes here. And if I do show interface fastnet 24 switch port, what I'm looking for here is that we have the administrative trunking encapsulation.1q, operational trunking is .1q, and we are actually an operational trunk. If I do show CDP neighbor, I should be seeing my Cat2 on fastnet 24. So now I have basics in place. Now, let me configure, just on Cat1, I'm going to start by saying VLAN 100, and let me create VLAN 101. And here I'm going to say private VLAN, primary. So I can do that pre-configuration when I create the VLAN. And here I'm going to say private VLAN secondary. So this is the first thing that I'm going to paste in. So this goes to a, oh, sorry, not secondary. Oh, silly me. Isolated. It is a secondary one, but you actually need to declare it as isolated. So if I do show VLAN, private VLAN, this is going to be the output if I run this command now. Now, this might be a little surprising because didn't we just declare this one here as the isolated? Where is it here in the output? Well, just like when you create the VLANs, unless you actually exit the VLAN configuration mode, this command here did not actually take effect. So what I'm going to do here is just type exit and then type show VLAN private VLAN. And again, I just want to show you the output, how it looks when it's actually broken. So this is not good output. This is not what you want to see when you're configuring private VLANs. Why is that? Because take a look. What we have here is we have VLAN 100 as the primary VLAN. We also have VLAN 101 as the isolated VLAN. But what we don't have is an actual association between them. There is no relationship between VLANs 100 and 101. So this is that one part, this is this one bit that actually needs to be configured, that needs to be added in the primary VLAN to actually make it work. this is that configuration that I was talking about. So this is now missing. What we need to do is configure the primary VLAN. We need to configure the relationship between the primary VLAN and the secondary VLAN. Now, the way we are going to do that is very, very simple way. So what I'm going to do now is, again, in my notepad, in the primary VLAN configuration, I'm going to say private VLAN association, and I'm going to add 101. So again, going to come in and paste this in, and remember again, if I run the command show VLAN private VLAN now, my command has not taken effect. I actually have to exit from this mode or go into another VLAN. I just have to move to some other place in the configuration before this takes effect. Now, this is the output that you do actually want to see, because with this output now, we can see that the primary VLAN 100 is associated with the secondary VLAN 101, and we can see that this is actually an isolated VLAN this time. So this is now correct configuration. We can still see here that no ports have actually been associated with any of these, but this is the basic. This tells you that the configuration is correct. So this here is not good. This configuration here, as we had it before, is not good. This one here is okay. This is what you want to see. Now, the thing that I mentioned before is that you can have only one isolated VLAN per primary VLAN. Let's try to create another one. So I'm just going to say VLAN 200, let's say 201, and I'm going to say private VLAN isolated. So nothing prevents me from actually creating another isolated VLAN. So if I do show VLAN private VLAN, I will see that I actually do have this second isolated VLAN. But take a look at this. It is not actually associated with any primary VLANs. Now, what I cannot do is associate this VLAN. So where is that command that I associated? I cannot associate this VLAN with the same primary VLAN as before. We can see here that the command was rejected, and we can see here that VLAN 101 is already associated with VLAN 100. Now, or actually that isolated VLAN is already associated there. So what I can do is I can change association like this. Well, actually no, I would have to remove the previous association. So I would have to say this, and then I can associate. Well, actually not even that, because it doesn't take effect. So I would have to say VLAN 100, and now, oh, let's see. Let me just turn this highlighting off. Do show VLAN. Let's see, private VLAN configuration all the way at the bottom. So this is now associated. Let's see what's the configuration here. So what I want to do is go to this VLAN, and I want to remove this association, exit from this. Now I can actually associate VLAN 201 with VLAN 100. But you see that I actually have to do quite an exercise to actually make this happen here. So you cannot have more than one isolated VLAN associated with the primary VLAN. So let's fix this configuration and actually have VLAN 101 associated with VLAN 100, just as we wanted to have it. So I'm going to go to VLAN 100, going to remove this association here, and let's try now to just associate directly this one. Won't allow me to do that. So I have to remove this, exit, VLAN 100, and now I can actually associate 100. Again, don't forget to exit the VLAN configuration mode. So show VLAN, private VLAN. Now what I should be seeing is again the correct configuration, that with our VLAN 100, our primary VLAN 100, we have 101 isolated associated with it. But again, an empty port list. So now that we have actually configured this stuff here, we have to work on configuring the ports. So what we need to do here is we need to configure this as an isolated port, as a port in isolated VLAN, and we want to configure this port here as the promiscuous port in VLAN 100, associated with the secondary VLAN 101, just as I explained earlier. Now, to do that, we actually need to replicate the configuration on switch 2, because currently what we have is just configuration on switch 1. Remember, there is no VTP now in place because we are using the transparent mode to actually replicate our VLAN configuration from switch 1 to switch 2. So we have to do this manually. So I'm going to go here, and actually I'm going to use my text editor. Where is that? Here it is. So I'm just going to repeat the same configuration, and remember, this needs to be done in 2 steps. I'm just going to repeat this configuration on my cat2. Again, going to exit and do show VLAN, private VLAN, and again, I should be seeing the configuration that I want. Primary VLAN 100. Oops. That's not exactly what I wanted to do. So primary VLAN 100 here, associated with secondary VLAN 101, and secondary is isolated port. So far so good. Now, let's configure these ports. When I'm configuring the ports, the first thing that I need to do is determine whether the port or which type port should be. Now, in private VLAN context, we can have 2 types of ports. We can have host ports, or we can have promiscuous ports. Now, host ports can belong to either isolated VLAN or the community VLAN, but they are in both cases called host ports. Now, when we configure promiscuous ports, we need to map secondary VLAN to these ports, and we can have multiple secondary VLANs mapped to the promiscuous port. So this port here on switch 1, this will be the host port in isolated VLAN, and this here will actually be promiscuous port. So going to our switch 1, I'm going to go to interface fastnet 01. I'm going to say switch port. Let me just move this on top. So switch port mode, private VLAN, and again, I will have 2 options, host or promiscuous. This one needs to be host. Now, this just tells me what type of the port this is going to be. What I still need to do is I need to associate primary and secondary VLANs with port. For host ports, the keyword to remember is host association. And for promiscuous ports, the keyword that we have to remember is mapping. And of course, due to the iOS consistency, the world famous consistency of iOS, there are of course multiple ways we can do this. So let me show you that. So going here to our terminal, what I can do is switch port private VLAN, and here I can either use association command, and as you will see, there is one more thing that I have to do there, or I can use host association. Now, I would recommend that you use the host association, but you can also use the association. So let me just show you that briefly. So if I use the association keyword, here I can either tell it, okay, you are a host, or you are going to be using the mapping. So using this association command, you can have, I would think, more consistent approach in the command line between configuring host ports and promiscuous ports, but it might be difficult to remember. It might be more typing. As I said, just 2 ways of accomplishing the exact same thing. Now, to make it even more fun, I'm going to use this version of the command. So I'm just going to say association host, and here I have to specify the primary VLAN, which will be our 100, and the secondary VLAN, which will be our 101. Now, take a look at the configuration of the port. So what actually ended up in the configuration is the host association command. So even though I have actually used this format of the command, what I ended up with is this, consistency. But anyways, just two different ways of accomplishing the exact same thing. So now, this interface here, fast Ethernet 01, is actually associated with primary VLAN 100 and the secondary VLAN 101, which is our isolated VLAN. Now, the port is shut down, so I'm just going to do no shutdown, and just to speed things up, I'm just going to make it port fast. Now, on Cat2, our fast Ethernet 06 needs to be a promiscuous port. So I'm going to say switch port, mode, private VLAN, and here I'm just going to use the promiscuous keyword. I can use switch port, private VLAN. Again, two different ways of accomplishing the exact same thing. I can use mapping or association mapping and then the commands. Let's use the association mapping 100, and I want to map the secondary 101. Again, if I take a look at the config of the port, what I actually ended up in the running config is actually mapping command, even though I have used the association mapping here. So again, just two different ways of accomplishing the same thing. So spanning tree, port fast, and I'm going to say no shutdown here. Now, let me bring my R1 and R6 into the mix. So I'm going to connect to R1 here, and I'm going to connect to R6 here. Let me just move R1 to the left-hand side of Cat1. And what I'm going to do here is, let me just configure a subnet between them. So I'm just going to use 192.168.100.0/24. So I'm just going to use .1 here and .6 here. So on R1, again, I'm starting with all blank configurations, so I'm just configuring everything from scratch. So IP address 192.168.100.1, no shutdown here. So I have this here, no shutdown. I did no shutdown on this side. So let's see if I can actually ping between R1 and R6. So what I'm going to do now is I'm just going to send a couple of pings to R6. And as I can see, my ping was actually successful. Well, that's what I expected. But let's see how this actually worked. So what I'm going to do next is, on switch 1, I actually have a server running Wireshark. So it is connected here to port fast Ethernet 03. So what I'm going to do is I'm going to take a copy of the traffic going to and from fast Ethernet 24, and I'm going to send it to my Wireshark. What I'm going to be looking for are the VLAN tags going in this direction and VLAN tags coming back. So let's bring in our Wireshark into the mix. So what I'm going to do here is I'm going to start capture on Cat1, and I'm just going to run very simple filter. I'm just going to capture only ICMP traffic. This is the only thing that I care about for now. And then on Cat1, I'm going to create my span session. So I'm just going to say monitor session 1 source interface fastnet 24. I want both incoming and outgoing traffic. I'm going to say monitor session 1 destination interface fastnet 03, and I actually wanted to replicate the VLAN tag. So interface fastnet 03, I'm going to say no shutdown there. So if I do show interface fastnet 03, and it says here that the interface is up and line protocol is down. It's monitoring, which is exactly what I wanted. So let's now go to R1 and let's send one ping. So one ping has gone out, And here I have it in my Wireshark. Now, what I'm going to be focusing is this. So these are my VLAN tags. This traffic here that I'm seeing was echo request going from R1 to R6. So this is this traffic here. And we can see here that on the trunk itself, this was actually sent with VLAN ID of 101. Now, what about the return traffic? How did the return traffic come back? Well, let's take a look at the return traffic. So this was the echo reply. This was the traffic going from R6 to our R1, and we can see here that it was actually sent with VLAN ID of 100. So if you remember that thing that we talked about earlier, when we have two switches here, and when we have the isolated port and when we have the promiscuous port, the traffic going from the isolated port to the promiscuous port on this trunk here will be tagged with the secondary tag, and the traffic coming back here will be actually tagged with the primary tag. So this is how this communication works. Now, let's add one more thing to the mix. Actually, two more things to the mix. So we are continuing with this example here. So let me just do one thing here. What I want to do now is I want to add two more routers. So I'm going to add R4 here, and I want to add R7 here. Now, this is going to be FastNet 07. This will be FastNet 04. Actually, not that one, but this will be FastNet 04. This will be 00, and this will be 00. Now, these are going to be in the same subnet, but what I want to do here is actually I want to add them to be in the community VLAN. So this is going to be VLAN 102, and I'm going to create this as the community VLAN. So what I want to see with this is the communication between R4 and R7 and between R4 and R6, which again, remember, is the promiscuous port. So let's add our R4 and R7 to the mix, but before I do that, let me first create my VLANs. So what I need to do here is I need to create my new VLAN. So this will be VLAN 102, and it's going to be private VLAN community. So let me just add it to cat1. Again, I'm going to keep repeating this. Remember that when you create the VLAN, unless you exit from that VLAN configuration mode, the configuration will not take effect. So I'm just going to say exit here, and I'm going to do show VLAN private VLAN. Now, what I can see is that VLAN 102 has actually been created, that it is a community VLAN, and that this VLAN is not actually associated with any primary VLANs. Again, this is the thing that I need to do. I can also see that it's not associated with any of the ports. So I'm going to go into VLAN 100, and I'm going to say private VLAN association, and I'm going to add 102. I'm going to exit, do show VLAN, private VLAN, and now what I can see is that with primary VLAN 100, I actually have two secondary VLANs associated. So there is an association here. This is the isolated VLAN, one and only we can have, and this is the community VLAN. Now, even though in my example, I'm not going to be using any additional community ports, let's just for fun add another community VLAN to the mix. So I'm just going to say VLAN 103. I'm going to say private VLAN community. Going to exit here. Going to go to VLAN 100. And going to associate this one with my primary VLAN. So now, if I take a look at this, I will see that at this moment, with my one primary VLAN, I actually have 3 VLANs associated, one and only isolated VLAN, and I actually have 2 of the community VLANs. And I can have quotes any number of community VLANs associated. Now, I'm sure that there is a platform limitation on Cisco switches, but I have never been able to actually either hit that limitation or actually find out that information. But the RFC that I mentioned before, the informational RFC that Cisco published, the 5517, actually just says you can have as many community VLANs as you like. But as I said, I'm sure that there is a technical limitation there as to how many we can actually have. So this is the one of 2 that I actually care about. Now, let me replicate this configuration on Cat2 as well. So I'm just going to say here exit, and let me go to my text editor. Going to create private VLAN community. Let's create 102 and 103, and I'm going to say association 102, 103, just to have the same configuration as I have on the other side. So if I do show VLAN, private VLAN, this is what I actually want to see. Now, let's configure our port. So what I need to do here is I need to configure port 4 on switch 1, and I need to configure port 7 on switch 2. Both are going to be host ports associated with the community VLAN. So let's do that. So on Cat1, interface fastnet04, I'm going to say switch port mode private VLAN host, and I'm going to say switch port private VLAN. And again, remember multiple ways of solving this, so I'm just going to use the direct command, host association, primary VLAN, and secondary VLAN. Again, I'm just going to use port fast here to make things a little bit faster. Now, if I do show VLAN, private VLAN, what I can see here now is that fastnet04 has now been associated with this community VLAN. This is exactly what I want to have. Now, let's do the same thing on Cat2. So interface fastnet07, switch port mode private VLAN, host, and then switch port private VLAN, host association, 100, 102, spanning tree port fast. Let's do no shutdown, show VLAN, private VLAN, and this is what I want to see. Now, did I do no shutdown on Cat1? I'm not entirely sure, but what I want to do next is I want to add my R4 and R7 to the mix. So let's move R4 here. And again, I have no configuration on these routers, so let me add that. Interface fastnet00, IP address 192.168.100.4, no shutdown, and on R7, oops, let's configure the interface, it's much better. So, at this moment, this is the setup we have. So all these 4 routers are in the same subnet. We know that R6 is connected to promiscuous port, and we know that R1 is isolated. R4 and R7 are in the same community. So what we should have here is the communication between R4 and R6, R4 and R7, but what we should not have is the communication between R4 and R1 and R7 and R1. Let's give it a try. So I'm going to go to R4 now, and I'm going to try to ping R6. Let's see if this works. This doesn't work. Now, is this expected or unexpected? Maybe I missed something. Let's try communicating with R7. Now, this does work. Well, you know that we have that Wireshark running. Let's see what's going on in Wireshark. So I'm going to ping R7, and again, I'm just going to send one ping. So before I proceed, let me just restart this capture, going to go back here and send one ping only. Now, this first packet that we are looking for, so this is the communication between R4 to R7. So the first packet is right here. We can see that in this direction here, VLAN 102 was used. Now, what about the echo reply? What was the tag used on the return traffic? Let's take a look at that. Take a look. So the return traffic here used also 102. So when we have two switches, just like we had in our example here, when we have two switches here, the communication between the isolated port here, the community port and community port, when it traverses the trunk, is actually going to be using the secondary VLAN ID in both directions, just like we described before we started configuring and actually looking what is happening in the frames. But why can't R4 communicate with R6? Well, let's take a look at that example as well. So I'm going to go again to R4 and I'm going to send just one ping to R6. Now, if I go back to my Wireshark, I'm not even getting that one request. Now, let me show you why. So I'm going to clear this filter. And let's just filter out all the STPs. And this is the problem. So we can see here that we actually had an ARP request. So if I modify this filter here to show me ARP or ICMP, now we can see that my R4 is actually sending the ARP request, but nobody is responding. Why wouldn't R6 respond to ARP request? Well, because we haven't actually configured this port to be part of this community VLAN. We forgot that communication. This traffic here, remember, going from a host port over the trunk port will be tagged with the secondary VLAN ID. If this secondary VLAN ID is not associated with this port, the traffic will not be sent out. So if you take a look at R6 configuration, or actually the port facing R6, what we can see here is that this port is indeed configured to be the promiscuous port, but only secondary VLAN 101 has been mapped to it. What we need to add here is VLAN 102 as well. So this is what needs to be fixed before we can have the communication between R4 and R6. Let's do that. So interface fastnet 06, I'm going to say switch port mode, switch port, private VLAN, mapping 100, and here instead of just retyping the whole thing, I can just use the add keyword. So I'm just going to add 102 to the mapping. So if I do show run interface fast ethernet 06, what I should be seeing now is that both VLANs 101 and 102 are now mapped to this promiscuous port. So if I go to R4 now and I repeat my ping, I am going to get a response. Now there's a 2-second ARP timeout. This is why the first ping failed and I had to ping twice. But if I go to my Wireshark, what I'm going to be seeing now is the ARP request going out. There it is. And I'm seeing the ARP response, and here I can see my pings. Now, as we might expect, the traffic going from my R4 is actually tagged with the secondary VLAN ID, but the traffic coming back here is mapped with the primary VLAN ID. So here in this scenario, we had R4, which was communicating with R6, and remember, this port here was promiscuous. This port here was just a host port. So the traffic going in this direction was tagged with the secondary VLAN ID. The traffic in this direction was tagged with the primary VLAN ID. So this is how private VLANs operate when everything is fine and everything is configured right. But this doesn't mean that private VLANs are actually a magic bullet and that they can provide these services always. There are situations when private VLANs can be misconfigured and you can actually have a situation in your network which leads to very undesirable results. Now, remember, the number one thing about private VLANs, or number one requirement on most Cisco switches, is that you are running VTP in transparent mode, which means that configuration on this switch does not necessarily need to match the configuration on this switch. And this can lead potentially to undesirable results. So what we had right now is the situation that both switches were configured properly. Let me add another switch to the mix. So what I'm going to do now is I'm going to have switch 1, which is connected to switch 2. So this doesn't change. So this is port 24, this is port 24. Now, what I'm going to add now is switch 3. And I'm going to connect it like this to switch 1. So this is going to be port 22, and this will be port 22. Now, I will shut down all other ports on switch 23. And what I'm going to do on switch 3 here is I'm going to add a port in VLAN 102. So I'm not going to do anything with this port. I'm just going to add it there, and it will be actually Fast Ethernet 03. Now, why Fast Ethernet 03? Because this is actually also connected to my Wireshark. Now, there will be no IP address on this side, but I'm not really interested in actually getting any meaningful traffic to and back. Now, this VLAN 102 here will be created just as the regular VLAN on this switch. So let me do that. So I'm going to add switch 3 to the mix now. And again, as I said, I'm doing all this on the blank configuration, so there is no pre-configuration in place. So interface range, fastnet 01, 23, actually to 20, and then 23 to 24, gigabit 01 to 2, and I want to shut these ports down. Interface fastnet 22, switch port trunk encapsulation .1q, switch port mode trunk. Let me put this here. And on cat 1, interface fastnet 22, do show run interface fastnet 24. What I'm going to do is just copy this configuration. No shutdown. So what I should be seeing now, show CDP neighbor. I should be seeing cat 3, there it is. Now, let me go to cat 3, and I'm just going to say VTP mode transparent, and I'm just going to say VLAN 102. Now, as you noticed, here on my switch 3, I have not created VLAN 102 as the primary VLAN, as the private VLAN. What I have done there is I have just configured this as the regular VLAN. So there is no private VLAN configuration here. Nothing has been configured private VLAN wise. So I'm going to go to interface fastnet 3, going to say switch port mode access, switch port access VLAN 102, spanning tree port fast, no shutdown. So let me go back to my Wireshark here. And I'm going to say capture, just going to change the interface on which I'm capturing. So I want to capture from my cat 3. Let's start that capture. And going back to terminal here, do show interface fastnet 03. I can see that that interface is up. Now let me go back to my R4, and I'm just going to ping the broadcast address in VLAN 102. So if I go back to my Wireshark, take a look at this. My Wireshark actually received this traffic. Why did it receive it? Is this a community VLAN? No, it is not a community VLAN. It is just a regular VLAN on cat 3. So this is something that you need to be on a lookout for. is that when you are configuring private VLANs, your configuration in your network needs to match. If your configuration doesn't match on different switches, you could have a situation when you have an undesirable communication. Now, was this a desirable result? It might or might not have been desirable. But one thing is certain, our Cat1, or I should say the host here in a community VLAN, R4, was able to send traffic to our Wireshark listening station here, and this port was not configured as nothing special. It was just an access port in VLAN 102. Why is that the case? Because remember, even though two VLANs are in use here, the primary VLAN 100 and the secondary VLAN 102, when the traffic goes over the trunk, the traffic coming from the community VLAN or an isolated VLAN will actually be tagged with the secondary VLAN going out. Let's take a look at what happens here. So here in this scenario, I have R6, and remember, this is a promiscuous port. So I'm going to ping the broadcast from this port as well here. So let's go there. So R6, and I'm going to say ping 192.168.100.255. I'm sending again a broadcast ping. Let me interrupt this. So going back to our Wireshark, did I actually receive this traffic? This was not it. This was something else. This was who has .6. This was R7 asking, so this wasn't the ping that I was sending. This was something totally different. Let me send that broadcast again. So I'm just going to repeat it once. Take a look. Am I getting that ping? No. Now, is this a desirable result? It might or might not be. Now, the reason why I'm not getting this traffic is because this is a promiscuous port. When the promiscuous port sends traffic and this traffic goes over the trunk, remember, the primary VLAN ID will be used. Now, primary VLAN ID in this case is VLAN 100. Now, VLAN 100, when it arrives on this port here, will be dropped because we have not created VLAN 100 on switch 3. Let's do that. So let's go to our terminal and let's on switch 3 create VLAN 100. So now, if I do show VLAN, I will see that I have both VLANs 100 and 102 created. Let's go back to our R6, and I'm going to repeat the ping. Again, sending just one ping. Let's go back to Wireshark. Where is the ping? There is no ping. Again, even though we have VLAN 100 configured now, the traffic arriving here is in VLAN 100. And remember, this is just an access port in VLAN 102. So this communication here was possible in this direction, and this communication here was not possible because it was coming from a different VLAN. Now, if I had an IP address configured on my port here, would I be able to actually send traffic back to this VLAN here? Let's take a look. So what I'm going to do now is on switch 3, I'm going to add another router. So this will be R5, and it will be behind switch 3. So again, absolutely no configuration here, and this will be R5 interface fastnet 01 in this case. So going to say no shutdown and going to go to cat 3. And pretty much just repeat this configuration here. Now, if I go to R4 and I try to ping 255, let's try one more ping. Now we can see that we are actually getting a response from R5. Oops, why is this happening? It's just beyond me. I do apologize about that. So here we can see that we actually got the response from R5. Why is that? Well, very simple explanation. We have sent traffic here in VLAN 102. It arrived to port. So this is R5, 01 here, port 05 here, which was again configured as an access port in VLAN 102. So as far as this switch is concerned, this is just regular VLAN traffic, and the response was tagged when sent back in VLAN 102. Now, if you remember this case here, what is going to be the traffic encapsulation here when one community port, this one here, communicates with this community port? It's going to be 102. Now, when the return traffic arrives to switch 1 here thinks it's another community port talking back to it, but it isn't. We know it is not. Again, this may or may not be the result you're looking for.